Hi folks, this is Linear Algebra Quiz 20. We're asked to use the Gram Schmidt process as discussed in class to get an orthonormal basis from P2 from this regular basis for P2. So the inner product we're using is this integral inner product that we've talked about before in class. Okay, so t squared, t, and 1. So I think of those as my three vectors. x1 is t squared, x2 is t, x3 is 1. And so the first step in the orthogonalization process is to orthogonalize x2 and x3 with respect to x1. So I'm going to replace x2 with x2 minus its projection onto x1. And I'm going to do the same thing with x3. Alright, these two new vectors will be now orthogonal to x1. Okay, so how do I go about doing that? Well, I need to get the inner product of x2 with x1, x3 with x1, and x1 with x1. So, let's do that. So the inner product of x1 with itself. So this is the length of this vector x1. So according to the inner product, I multiply them together and then integrate them. So I'm integrating from 0 to 1, t squared times t squared, that's t to the 4th dt, and I get 1/5. The inner product of x2 with x1 is the inner product of t with t squared. That's the integral from 0 to 1 of t cubed dt, which is 1/4. And finally, the inner product of x3 with x1 is the inner product of 1 and t squared, which is the integral from 0 to 1 of t squared dt, which is 1/3. So that means that the projection of x2 onto x3, onto x1, well, by definition, that's the inner product of x2 with x1 over the inner product of x1 with itself times the vector x1. The inner product of x2 with x1, we found that to be 1/4. The product of x1 with x1 is 1/5 times x1, which was t squared. And so I get 5/4 t squared. So that means that the new x2 is going to be x2 minus its projection, which is going to be t minus 5/4 t squared. The projection now of x3 onto x1 is the inner product of x3 with x1 over the inner product of x1 with itself times x1. We found that to be 1/3 divided by 1/5 t squared, which if you do the gymnastics is 5/3 t squared. So this tells us that the new x3, well, that's x3 minus its projection onto x1 is going to be 1 minus 5/3 t squared. Okay, now it's probably worth a moment of your time to actually check that this x2 is orthogonal to this x1. If I take these two, multiply them together, integrate from 0 to 1, that I do get 0, and the same thing with x3 and x1. Now we're ready to move on to step 2, which is we want to orthogonalize x3 with respect to x1. So I'm going to replace x3 with x3 minus its projection onto x2. And as we saw in a previous checkpoint quiz, doing this will not destroy the orthogonality we already have with x1. So what do I need to construct the projection of x3 onto x2? Well, I need the inner product of x3 with x2, which is the inner product of 1 minus 5/3 t squared with t minus 5/4 t squared. That's, by definition, the integral from 0 to 1 of the product of these two polynomials. The integral from 0 to 1, I multiply out. I'm going to have 1 times t, which is t. I'm going to have minus 5/4 t squared. I'm going to have minus 5/3 t cubed plus 25/12 t to the 4th. So this gives me 1/2 t squared minus 5/12 t cubed minus 5/12 t to the 4th plus 25 over 60, which is going to be 5/12 t to the 5th, all from t equals 0 to t equals 1, which will give me a half minus 5/12 minus 5/12 plus 5/12, so minus 5/12. 6/12 minus 5/12 is 1/12. The last thing I need to find the projection of x3 onto x2 is the inner product of x2 with itself, so the length of this new x2, which is t minus 5/4 t squared, t minus 5/4 t squared. So that's the integral from 0 to 1, t minus 5/4 t squared times t minus 5/4 t squared dt, which is the integral from 0 to 1. I'm going to get t squared minus 2 of 5/4 t cubed. So it's going to be minus 5. Nope. I'll redo that. I'm going to get t squared. I'm going to have minus 5/4 t cubed minus another 5/4 t cubed. So it's going to be minus 5/2 t cubed plus 25/16 t to the 4th dt. So I integrate this, I get 1/3 t cubed minus 5/8 t to the 4th plus I get a t to the 5th over 5, that's going to give me 5/16 t to the 5th. And this is from t equals 0 to t equals 1. So I get 1/3 minus 5/8 plus 5/16. So we get a common denominator of 48. Multiply that by 16, minus, multiply that by 6, plus, multiply that by 3, and you're going to get 1 over 48. Okay, so we have all the ingredients now to get the projection of x3 onto x2. So by definition, this is the inner product of x3 with x2 divided by the inner product of x2 with itself times x2. The inner product of x3 with x2 we found to be 1/12. The inner product of x2 with itself we found to be 1/48 times x2, which is the polynomial t minus 5/4 t squared. So you do the fraction gymnastics and you get 4. And so you get 4t minus 5t squared. So the new x3 is x3 minus its projection onto x2, which is 1 minus 5/3 t squared minus 4t minus 5t squared. So we're going to have 1 minus 4t plus, we're going to have negative 5/3 t squared plus 5t squared. So it's going to be 15 minus 5, it's 10 thirds t squared.